Today I'm going to prove the sum of the first n whole numbers is equal to n times n plus 1 all over 2, and we're going to do this by induction to reinforce what I did in the last video. So for induction, we know we have to prove the base case. So I have to prove this when n is equal to 1. So the summation from k equals 1 to 1 of k is just plugging in 1. So this is 1. Now we have to verify that this is equal to this formula, so plug it in 1, and then this will be 1 plus 1 all over 2. Remember that we're just plugging in for n at 1s. So this is going to be equal to 1 times 2 over 2, which indeed is equal to 1. Now 2, I have to assume it for, say, some upper m. So the summation from k equals 1 to m of k is equal to m times m plus 1 all over 2. So this is what we're going to assume. Now the third step, if I can verify that this works for 1 bigger, the summation from k equals 1 to m plus 1 still follows this formula, then we have proved it. So what we know is this is going to be equal to 1 plus 2 plus 3 plus 4 plus all the way to m plus 1. Now, right before m plus 1 is actually going to be equal to m, and then we'll have an m plus 1 right after that. Now, what we do know is this part of the formula, up to m, is this assumption. So this is going to be equal to m times m plus 1 all over 2, and then I still have this m plus 1 out here. So what I'm going to do is I'm going to factor an m plus 1 out of both of these things, or I can multiply top and bottom by 2, which will do the same thing. So this is m times m plus 1 plus 2 times m plus 1 all over 2. So top and bottom of this by 2 will give us this piece. Okay, so finishing this up, this is going to be equal to, pulling out an m plus 1, this will be equal to m plus 1. I'm going to be left with m plus 2 all over 2. And that verifies our formula, because what you do is the summation of this is going to be equal to this upper bound plus 1 bigger divided by 2. And that's what this is. This upper bound plus 1 bigger divided by 2. Please subscribe.